Today we're going to talk about discrete and continuous functions. Discrete, when we're talking about them in terms of functions, is when we're talking about the domain. Now remember, when we learned about domain, the domain are the x values, they're the input values that we'll put in for these different functions. Now when we're talking about discrete, the discrete means that the set of input values that consists of only certain numbers in an interval. So we have the example of integers 1 to 5, but they're integers. Integers are whole numbers. So we only have 1, we have 2, 3, 4, and 5. We don't have 1.5, we don't have 2 3/4. It's just those exact numbers. So that's why, and it's hard to see it on this sheet of paper, but you just have the dots here. There's no line connecting them. Now, continuous domains is just that. It's all of the numbers in the interval. So it's all numbers 1 to 5, which means it's everything in between. So we have the parts of the different numbers. So we can have 3.2, 2.5, 4.9. So we have that straight line that goes all the way through. So now we're going to start and do a little example to kind of show you how it is in terms of graphing a linear equation. So it says the function y equals 15.95x represents the cost y in dollars of x tickets for a museum. Graph the function using a domain of 0, 1, 2, 3, and 4. So we're going to graph it first. Then, is the domain discrete or continuous? All right, so first off, just like we've done in previous lessons, we are going to use domains of 0, 1, 2, 3, and 4. Now remember, if the domain is 0, 1, 2, 3, or 4, those are your x values, your input values. So we're just going to plug them into the equation to find out y. So as we do that, we're going to do 15.95 times whatever numbers we get. So go ahead and fill out your table and then check back to check your answers. All right, I went ahead and completed the table by just plugging in our domain or our inputs or our x values into the equation. I also went ahead and started labeling my graph that we're going to graph right now. I made sure to label the x values as tickets and the y as costs. So now we're going to talk about actually graphing it, because the domain is something that we're going to have to discuss in terms of graphing. So first off, I'm going to plot the points. So we start at 0, 0. We go over 1 up to 15.9. So I'm kind of guesstimating. As you can see, I've gone up by tens by skipping every other line. So I'm technically going up by 5s. Then at 2, I go to 31.9. Again, we're going to just guesstimate where our points go. 3 is 47.85. And then our 4 is going to be 63.8. Okay, so those are our points. Now let's talk about this domain. The domain, the x values. We're talking about the tickets for a museum. Okay, so we're going to discuss if it's discrete or continuous. Now, continuous is where you can have portions of the number, so 1.5 and 3 3/4. And with tickets, you can't do that. You can't split a ticket in half. So the domain is a discrete domain because you can only have integers or whole numbers for our domain. You can't split a ticket in half. You can't say, hey, I want 4 1/4 of a ticket when you're going to a museum. So because it's discrete, we do not connect the points. We just keep the points as is and leave it. So we're done. Let's go ahead and move to another. So our example here is the function of m equals 50 minus 9d represents the amount of money in dollars, m, you have after buying D DVDs. So first we're going to graph the function, then decide if the domain is discrete or continuous. So they don't give us a domain this time to plug in, so we're just going to plug in a couple different points. So we'll do 0, how about let's do 2, and then let's do 4. So go ahead and figure out your answers here, and then we'll check back to see what we got. Try to use mental math if you can. All right, I went ahead and filled out the table, but I also showed what my axes were labeled and went ahead and labeled that as well. Now, the problem did not tell us what our x values were or what our y values were. However, I went ahead and determined what the independent variable was. Now, the independent variable, which is again our domain or our x values, is the amount of DVDs that we buy. we get to determine that. That is what we choose to do. We can choose to buy 5 DVDs. We can choose to buy 3. We can choose to buy 0. Now, the dependent variable, it depends on how much money we have spent on our DVDs. So the money left over is dependent upon how many DVDs we buy. So that's why it's our y-axis. That's why it's the dependent variable. That's why it's our output, our range. So we have those labeled. Now we're going to plot our points. So at 0, we go to 50. At 2, we go up to 32. And then at 4, we're going to go up to 14. Okay, so now before we draw any line or whatever, we have to decide if the domain is discrete or continuous. The domain, which is our x value, is talking about the DVDs. Now, remember, if something's continuous, we could buy part of something or break it into parts. Discrete is whole number. So when we're talking about DVDs, it is again discrete domain because we can't buy 1.5 DVDs. We can only buy 1, 2, 3, or 4, or 5, however many we can afford, not parts of them. So it is a discrete domain, and we have to just leave our graph as it is. We do not connect the dots. All right, now let's try the next one. You guys are going to go ahead and try and figure out this on your own. So a cereal bar contains 130 calories. Now the number of calories consumed is a function of the number of bars eaten. Make sure you make a t-chart and try to figure out what your independent and dependent variables are. Go ahead and pause the video, and then you can check back with me to get your final answer. All right, so here's what I got so far. I have a t-chart that I put together, but first I had to determine what my independent and dependent variables were. The bars that we ate were independent variables because you can decide how many bars you're going to eat. And then the dependent variable is how many calories you get from eating however many bars. So I went ahead and just picked 0, 1, 2 for my domain, our x values. And I also made my function to an equation. It's 130 calories per bar, so you multiply. So now I'm going to go ahead and graph. I have 0, 0. When I have 1 bar, I consume 130 calories. At 2 bars, I go up to 260. Now I have to determine is my domain discrete or continuous. The domain is the amount of bar that I eat. It is actually continuous, so I can connect the dots. It's continuous because I can choose to eat 1.5 bars. I can choose to eat 3 3/4. Okay, it determines how many bites I take. So it is a continuous domain, and that means I connect the dots, and we are done. All right, try this one completely on your own, and tell me again if the domain is discrete or continuous by the end. If it is discrete, you do not connect the dots on the graph. If it is continuous, you do. And then check back to see what your answers are. All right, so here is what I have. I went ahead and created the function from what it told us. We had a 20-gallon bathtub, so we started 20 gallons, and then we went down at 2.5 gallons per minute. So it was draining, so we were emptying the tub. So our amount in the tub of water should have gotten less as time went on. I went ahead and plugged in some numbers, and after 2 minutes I found that it was 15 gallons in the tub. After 1 minute it was 17.5, and I did the math there. Now I already showed you, but the domain in our graph is going to be continuous because we're talking about minutes here. That's our x value, the domain, and you can have parts of a minute, the decimals, the fractions, and whatnot. And so you can actually find out what the different parts are of that minute. You can break it into pieces. So it is continuous, and I did connect the dots. Now we have a multiple choice question that's also talking about domain and if it's discrete or continuous. It says you conduct an experiment on the speed of sound waves in dry air at 86 degrees Fahrenheit. You record your data in a table. Which of the following is true? So we're talking about the domain here. As we've talked about this entire time, the domain is the input. We're really only looking at this column right here, guys. Okay, so we're talking about time in seconds, okay? As I'm looking at this, I'm trying to see, okay, can I cut seconds into pieces? And if you've watched any sporting event or anything with a stopwatch, you actually can. You can have 1.5 seconds, 3.25 seconds. So you can cut it into pieces. So because of that, we know that it's a continuous domain. So I'm crossing out my options where it talks about discrete domains. Now we're actually talking about the range that we have for the domains, what numbers we have. We have from 2 to 10. So now I'm going to decide, okay, which works with it, and it is B. The domain is greater than or equal to 2, less than or equal to 10, and it's continuous. So that's going to be our answer. Now, as our very last problem, you're going to look at the input and the output. Go ahead and decide if this domain is discrete or continuous, and please explain what it is. Pause the video and see if you can explain it correctly, and see what your answer is when you check back. Now, the domain is the input. It's the number of stories in a building. It is discrete. You cannot have 2.5 stories in a building. The building has a set number of stories that has to be a whole number. Now, I know some of you might be thinking, well, technically you can be continuous because if you're on an elevator, it brings you in between buildings. That is true, but when you're talking about taking the height of a full building, you have to take into account every single story to the exact integer whole number amounts, not partial amounts. So it is a discrete domain.